Hi, this is lesson 13.1, Use Trigonometry with Right Angles. So we're going to look at some rules that should look familiar because you used them last year. So they're not new at all, but they're something that we've got to remind. So 13.1 is use trigonometry with right triangles. And think way back to last year, we had sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. And look down here, don't forget our favorite I'm having a hard time saying that word, trigonometry phrase for the basic trig functions, and that was so, ka, toa. So that was sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. So now I'm going to introduce three new ones: cosecant, secant, and cotangent. So notice that our sine is opposite over hypotenuse. Our cosecant is the reciprocal of that, hypotenuse over opposite. And so we can also write cosecant of theta as being 1 over the sine of theta. Our next one, secant, it's hypotenuse over adjacent, and that's the reciprocal of cosine. So we can also write secant of theta is 1 over the cosine of theta. Then our last one here, COT, is cotangent. So cotangent is adjacent over opposite, and that's a reciprocal of the tangent. Tangent was opposite over adjacent. So we can also say that cotangent of theta equals 1 over the tangent of theta. I'm going to write these words down here just so you see how they're spelled, so you can get used to it. So cosecant, secant, and cotangent. That's what these stand for. Next, we're going to evaluate trigonometric functions. So we're going to evaluate the 6 trig functions of our angle theta right here in our triangle. And the first hint is we need to find all the sides first. We know this side's 8, this side's 15. We've got to find our hypotenuse. And notice this is a right triangle, so we're going to use a squared plus b squared equals c squared. So side squared plus side squared equals hypotenuse squared. So one side is 8 squared plus another leg is 15 squared equals our hypotenuse squared. So 15 squared plus 8 squared is 289, and that equals our hypotenuse squared. So we need to take the square root of both sides, and the square root of 289 is really positive or negative 17, but for our distance we're only looking at the positive. So our hypotenuse is 17. So this is 17, that's our hypotenuse. Here is our angle theta, so this 15 right next to it is our opposite. Is our adjacent, not our opposite. It's our adjacent. And across from theta, that's our opposite. So we've got our hypotenuse right here. 8 is our opposite, and 15 is our adjacent. So sine is opposite over hypotenuse, so that's 8 over 17. Cosecant is then going to be the reciprocal there, 17 over 8. Cosine is adjacent over hypotenuse, so that's 15 over 17. So secant is then, if we flip those around, do the reciprocal, that's 17 over 15. Tangent, opposite over adjacent, so opposite is 8, adjacent is 15. So then if we do the reciprocal for our cotangent, that's 15 over 8. Now, one thing I want you to remember is that if any of these fractions needed to be reduced, you would need to reduce them. We would always reduce these ones. Okay, so next we're going to solve a right triangle problem. So solve triangle ABC using exact values. What it means to solve a triangle is to find all the missing angles and all the missing side lengths. So here's what we know. We know side A equals 13. Angle B is 56 degrees. Angle C is 90 degrees. What we need to know the length of side B, the length of side C, and angle A. Now, angle A is definitely going to be the easiest to find because we know this is 56 and this is 90 degrees. So to find angle A, since all the angles add up to 180, we just do 180 minus the 56 degrees that we know and minus the 90 degrees that we know. So angle A here, angle A is going to be 34 degrees. So here's angle A, 34 degrees. Next, let's find side B. So in order to do that, I'm going to say this 56 degree angle, that's my theta. And I'm going to label all the sides based on that 56 degree angle being theta. So side C is my hypotenuse. Side B, that's across from it, that's the opposite. And side A is right next to it, so that's our adjacent. So now that I've labeled all of them, to find B, I want to find the length of B first. Well, what I can know is the side right here, A, is 13, and that's adjacent. And I want to know my opposite. So what uses adjacent and opposite? Well, tangent does. So we're going to use the tangent of 56 degrees equals opposite over adjacent. And then to solve for B, I'm just going to make these both fractions and cross multiply. So 1 times B, well, that's B equals 13 times the tangent of 56 degrees. So before you put this into your calculator, make sure your calculator is in degrees, not radians. And you can do that by looking at the mode. So if you put this in your calculator, B is about equal to 19.3. So B is 19.3. Now let's find C. So C is right here. That's my hypotenuse. And again, I know my adjacent and I know my hypotenuse. So cosine uses adjacent and hypotenuse. So I can say that cosine of 56 degrees equals adjacent, which is 13, over hypotenuse, which is my side C. And again, if I make these both fractions and cross multiply, 1 times 13 is 13 equals C times the cosine of 56 degrees. And to get C alone, I'm just going to divide by the cosine of 56 degrees. And do that to both sides. And that'll make these cancel, and it'll give me C alone. So if you put 13 divided by the cosine of 56 degrees into your calculator, you'll get about 23.2. So C is 23.2. Okay, let's look at this problem. It says if the sine of theta is 4 over 7, find the other 5 trigonometric ratios. Okay, so we know the sine of theta, and that's opposite over hypotenuse. So my sine is 4 over 7. So I'm going to label my triangle. Here's my right angle, and I'm going to pick either of my other 2 angles to be theta and label the triangle accordingly. So I'm going to pick this angle up here to be my theta. And if that's theta, well, here's my hypotenuse. That's my hypotenuse no matter what. Right next to it here is my adjacent side, and across from it here is my opposite side. So let's put our opposite and hypotenuse in since we know what they are. So this side is 4, my hypotenuse is 7. Let's find our missing side, and because this is a right triangle, we can use leg squared plus leg squared equals hypotenuse squared. So that's a squared plus 4 squared equals 7 squared. So if I subtract the 4 squared here, I have a squared equals, well, 7 squared is 49 minus 4 squared, that's 16. 49 minus 16 is 33. So to get a alone, I'm going to take the square root. So my adjacent equals the square root of 33. Now I'm going to put a little note here. We want exact values. So if you put the square root of 33 in your calculator, you'll get a decimal, and we don't want a decimal here. And if I think about it, there are no perfect squares that go into 33, so I cannot reduce that as a radical. I'm going to keep my adjacent side as the square root of 33. So we want exact values here. So if my sine of theta is 4 over 7, my cosecant of theta is going to be the reciprocal of that. That's going to be 7 over 4. Let's look at our cosine now of theta. Cosine of theta, well, your cosine is adjacent over the hypotenuse, so my adjacent is the square root of 33, and my hypotenuse is 7. And I've got a radical there, it's on the top, so I can keep that radical. My secant of theta is going to be the reciprocal of the cosine, so that's 7 over the square root of 33. Now here's the trick. You cannot have the square root of 33, a radical, in the bottom of this fraction. So we need to rationalize that denominator. So to rationalize the denominator, we're going to multiply the top and bottom both by the denominator. So I'm going to multiply the top and bottom both by the square root of 33. It's just like multiplying by 1. It just changes the way it looks, but it doesn't change the value. So the top is 7 square root of 33 over 33. And then looking, we've got to ask, does 7 over 33 reduce? And it doesn't, so there is nothing we can do. We're going to keep it exactly as it is. So I've now rationalized my denominator. So it's 7 square root of 33 over 33, and that would be my correct form. We're next going to do the tangent of theta. So my tangent is opposite over adjacent. So my opposite is 4 over my adjacent is the square root of 33. And I've got the exact same issue here that I just have. I have a radical on the bottom, which I can't have. So let's go through and rationalize that denominator. So I have 4 over the square root of 33. I'm going to multiply by the square root of 33 over the square root of 33. So at the top I'm left with 4 square root of 33. And on the bottom is just 33. So there is my rationalized fraction. So it's 4 times the square root of 30. That's a 33 over 33. I have to have it rationalized. So now I want the cotangent of theta, my last one. So I need the reciprocal of tangent, so it's just the square root of 33 over 4, and since that radical's in the top, it is perfectly acceptable. So let's try another solving a triangle problem. And we're going to first make a list of what we know and what we need to know. So looking at our picture right here, this is our theta. Okay, that's angle A. It's 37 degrees. So since we're on angles, let's look at the rest of them. Angle C, we know, that's 90 degrees. Angle B, we don't know, so we need to find it. Okay, let's look at our sides. Across from angle C is little c, so side C is 22. We don't know side A and we don't know side B, so we need to figure out what those two are equal to. So we said 37 degrees, that's our theta. To find angle B, remember the three angles add up to 180 degrees, so I can do 180 minus 37 minus our 90 degree angle. And if you simplify that, you'll find 53 degrees. So angle B is 53 degrees. Side A, let's do side A next. I'm going to give myself a little bit more space down here. So to find side A, let's label our sides according to theta. So if theta is the 37-degree angle, well, our side C, that's our hypotenuse. A is across from theta, so that's your opposite. And side B is right next to theta, so that's your adjacent. Okay, so let's look at what we know and what we need to find. So we know theta is 37 degrees. We want to find side A. So we want to find this one, that's opposite. And our hypotenuse is across from that. So opposite over hypotenuse, well, that's sine. So we're going to use sine of theta to write an expression. So sine of theta, which is 37 degrees, equals opposite, which is A, over hypotenuse, which is 22. I'm going to make these both into a fraction so I can cross multiply. So I have A times 1, which is A, equals 22 times the sine of 37 degrees. And if you put that in your calculator, again, remember you should be putting these into your calculator, making sure you can simplify them correctly. A is approximately equal to 13.2. So A is 13.2. Side B. So side B is right here. It's adjacent, and I also know my hypotenuse. So I think what uses adjacent and hypotenuse? Well, that's cosine. So I say the cosine of 37 degrees equals adjacent, which is my side B, over hypotenuse, which is 22. I'm going to make this into a fraction so I can cross multiply. 1 times B is B, equals 22 times the cosine of 37 degrees. So if you put that into your calculator, B is approximately equal to 17.6. So B is 17.6. And what you could do to check it, to make sure that they're right, is you could do leg squared plus leg squared equals hypotenuse squared and make sure it simplifies. So if you do 13.2 squared plus 17.6 squared, that should equal 22 squared. So that would be a great way to check, to make sure that your side lengths add up so that they make sense for a right triangle. And I did that earlier and it did work out. Okay, let's finish by trying a few story problems. So this first one, we're talking about elevation. It says you're measuring the height of your school building. Okay, so I'm going to draw our school building here. Here's EKHS. You stand 25 feet from the base of the school. So this is 25 feet that we're standing away. And we're going to assume our building's upright, so that's a right angle right there. The angle of elevation from a point on the ground to the top of the school. So here's my point on the ground to the top of the school. So there's my angle. My angle of elevation is right here. It says that's 62 degrees. So that's my theta. Estimate the height of the school to the nearest foot. So we're looking at the height here of EKHS. So now that I got my picture drawn in here, let's label these sides. So if 62 degrees, that's my theta. This 25-foot side is right next to it, so that is my adjacent. And then across from it, H is my opposite. So we have to think what uses adjacent and opposite. Well, that's tangent. So tangent of 62 degrees equals opposite, which is H, over adjacent, which is 25. So let's solve this. I'm going to make this into a fraction and cross multiply. So 1 times H is H equals 25 times the tangent of 62 degrees. And if you put that into your calculator, you'll find that the height is approximately 47 2/2 feet. So let's try an angle of depression. So an angle of depression is when you're looking down at something. So it says an airplane is traveling at 25,000 feet above the ground. So here's my airplane. Okay, and since I'm drawing it up in the air, I'm just going to make some dotted lines. Remember, this is 25,000 feet. As it begins its descent toward the runway, the angle of depression is 15 degrees. So what an angle of depression is if I draw a line going straight forward from the airplane and then draw an angle going downward, that would be my angle of depression. And it says this is 15 degrees. So remember, that's a very small angle. How far from the runway is the airplane? So if my runway is right down here at the bottom, then we're looking for this distance along here. So this is going to be a right angle, right up here, and this side is going to be 25,000 feet. So let's label our theta, opposite and adjacent. So 15 degrees is my theta. My distance, well, that's my hypotenuse because it's across from the right angle. And the 25,000 feet, that's your opposite. So we have to ask, what uses opposite and hypotenuse? Well, that's sine. So sine of 15 degrees equals opposite, so 25,000, over hypotenuse, and that's my distance. So I'm going to make this into a fraction and cross multiply. 1 times 25,000 is 25,000 equals the sine of 15 degrees times my distance. The d goes in the front. If I want d alone, I need to divide both sides by the sine of 15 degrees. So those signs cancel, so my distance is approximately equal to, and put 25,000 divided by sine of 15 into your calculator, and you should get 96,592 and 58 feet. Okay, we've got one last word problem here. It says a flagpole or building. So from a point on the ground 28 feet from the base of a flagpole. So here's my flag. I've got a point on the ground over here that's 28 feet away from the base of the flagpole. The angle of elevation to the top of the flagpole is 63 degrees. So an angle of elevation is an angle that's going upward like this. So here's my angle, and that's 63 degrees. Estimate the height of the flagpole. So we want to know this height over here. So let's label our angle and our side and then write a problem for this. So 63 degrees, that's my theta. 28 feet is right next to it, so that's my adjacent side. And my right angle is right here. So my hypotenuse, or my h, my height, that's going to be my opposite side. So what uses opposite and adjacent? Well, that's tangent. So I have the tangent of 63 degrees equals opposite, which is my h, over adjacent, which is 28. So I've set up my problem. Now I'm going to cross multiply. So I'll make this a fraction and cross multiply. 1 times h is h equals 28 times the tangent of 63 degrees. And if you put that into your calculator, you'll find that your height is approximately 54 95 feet. So this is the end of lesson 13.1. Please make sure if there's anything you didn't understand that you star it so that we can talk about it in class tomorrow, and have a great night.